Assalamu alaikum, my dear students. This is the 8th lecture of States of Matter. In the lecture number 7th, we have discussed the important law, that is the Dalton's law of partial pressures. What was the statement? What is the mathematical form of the Dalton's law of partial pressures? If we have the mixture of chemically non-reacting gases, 2, 3, 4 gases, the total pressure will be equal to the summation of their respective partial pressures. ये हमने उसमें डिस्कस किया था, उससे पहले भी डिस्कस किया था. And in that very lecture number 7th, then we have discussed the importance or applications of the Dalton's law of partial pressures. The first we have discussed, that is determination of प्रेशर ऑफ द ड्राई गैस. जो एक्वस मॉइस्ट आया, वहां पे एक्वस टेंशन भी आया था, वो कंसेप्ट वी हैव डिटरमाइंड दैट. अगर मैं आपको ये बोलूंगा हाउ यू कैन डिटरमाइन द प्रेशर ऑफ ड्राई गैस, आपको ये फार्मूला याद रखनी है. पी ड्राई, प्रेशर ऑफ ड्राई गैस विल बी इक्वल टू टोटल प्रेशर, दैट विल बी द मॉइस्ट मींस टोटल प्रेशर माइनस एक्वस टेंशन. ये हमने डिस्कस किया था. Then we have discussed the second application, importance of the Dalton's law of pressures to determine the partial pressure of a gas. How we can calculate the partial pressure of a gas from this point. फिर हमने वहां पे जो derive की थी equation, that is partial pressure of a gas, it is equal to mole fraction of the gas into the P total from this point. ये हमने derive वहां पे की थी. For example, हमारे पास component A है. If you have to determine the partial pressure of gas, how you can write partial pressure of gas A, it will be equal to mole fraction, जिसको हम काय कहते हैं, mole fraction of A. ये भी मैंने आपको बोला, ये काय A किसके बराबर होता है, it is equal to number of moles of A divided by total number of moles जितने होंगे. You can calculate it, काय A into the P total. Remember this point. You have to remember this point. If you have a mixture of 2 gases, 3 gases whatsoever, you can write PA is equal to chi A into P total, PB is equal to chi B into P total. You can write in the same way. But the question is how you can determine the partial of a gas. You have to remember the formula. Partial pressure of a gas is equal to mole fraction of the gas, that very gas, into the P total. And I have already mentioned that in the numerical problems P total will be given. And how you can determine the partial pressure of a gas? You have to calculate mole fraction of the gas. Mole fraction किसके बराबर होता है? For example, chi A, ये किसके बराबर है? Number of moles of A divided by number of moles of A. And we will sort out an important problem that is from your text. You can write this very problem, but base is this one. You have to mention this partial pressure of a gas. It is equal to mole fraction of the gas into you have the P total. This is the formula you have to remember. The question from your text is the very important problem, the question which comes in the exams. You have a neon dioxygen mixture. A neon dioxygen mixture. This is the point. It is clear here we have just 2 gases. One is neon and we have the dioxygen gases. Mixture containing. अब हम देखेंगे इसमें neon कितना है. Oxygen जो है that is 60.7 grams, containing 60.7 grams of dioxygen and 60.7 grams of dioxygen and 167.1 gram of neon, 7.5 grams of neon. Remember this point. 167.5 grams of neon. This is the problem from your text. A neon dioxygen mixture containing this amount of dioxygen and this amount of neon. फिर वहां पे क्या given है? The total pressure of this mixture. The total pressure of this mixture. Of this mixture, अब ये 2 gases है mixture here, neon and dioxygen. Of this mixture is 25 bar. Bar is the unit of pressure. I have already mentioned it. Now the question is calculate the partial vapor pressures of neon and dioxygen. This is the question you had to solve. Calculate the partial vapor pressures of neon. Neon का प्रेशर कितना है, ऑक्सीजन डाइऑक्सीजन का प्रेशर कितना. मैंने आपको और पार्शियल प्रेशर किसके बराबर होता है, पी टोटल इज गिवन. मैंने आपको ऑलरेडी बोला है ये जो पी टोटल इट विल बी गिवन इन द प्रॉब्लम. व्हाट यू हैव टू कैलकुलेट, यू हैव टू कैलकुलेट सिंपली द मोल फ्रैक्शन. ऑन दिस पॉइंट यू कैन सॉल्व इट एज, you can solve it. पहले आपको लिखना है सॉल्यूशन में, सिंस पार्शियल प्रेशर किसके बराबर होता है, पार्शियल प्रेशर ऑफ अ गैस. पार्शियल प्रेशर या यहां पे लिखने की जरूरत है, यू कैन डायरेक्टली सॉल्व इट अराउंड दिस पॉइंट. यू कैन डायरेक्टली सॉल्व इट. वी कैन राइट पार्शियल प्रेशर ऑफ डाइऑक्सीजन गैस O2. ये किसके बराबर होगा, इट विल बी इक्वल टू मोल फ्रैक्शन O2, मोल फ्रैक्शन ऑफ O2 इनटू इट इज P total. P total is given. You have to determine this one, but first you have to determine the mole fraction of dioxygen gas. ये याद रखना है on this point. It will be given. It is given. You have to calculate the mole fraction of O2. यहीं पे लिखेंगे. This is the first part. यहां पे लिखेंगे मोल फ्रैक्शन ऑफ O2 डाइऑक्सीजन. ये किसके बराबर होगा, नंबर ऑफ मोल्स ऑफ O2 डिवाइडेड बाय नंबर ऑफ मोल्स ऑफ O2 प्लस नंबर ऑफ मोल्स ऑफ neon. Because we have two gases, number of moles of the gas divided by total number of moles of the gases. Total number is number of moles of O2 and number of moles of. It means that to solve this part or to solve the second part, what is necessary? You have to determine the number of moles of O2 and number of moles of neon. You can now make this heading, calculation of number of moles of dioxygen and neon. First we calculate their number of moles. Remember this point. You can calculate as number of moles of O2. Mass given, that is perhaps 60.7 gram. Mass given divided by total mass. ये जो O2 है, एक ऑक्सीजन का 16 है, relative atomic mass 2 will be 32. It means that mass given, number of moles, this is a formula we have discussed it in the mole concept. Number of moles, mass given divided by the molecular mass. यहाँ पे molecular mass कितना है, 32. You can calculate. If you have the calculator, you can calculate it. 60.7 divided by 32. You will have 1.89 moles. ये याद रखना. This is the number of moles of O2. Number of moles of O2. You can calculate here number of moles of neon now. Mass given. What is the mass given? 167.5 mass given. जो प्रॉब्लम में दिया है, divided by atomic mass. Atomic mass of neon is 20. You can calculate this mass given 167.5 divided by 20 atomic mass. It is 8.37 moles. Dear students, to solve the problems on this calculation of partial pressure of a gas, you must have to determine the number of moles. This is the number of moles of O2 and this is the number of moles of neon. Now you can substitute number of moles of O2, number of moles of O2 and neon. What you can determine? You can determine the mole fraction of, पहले मैं यहाँ पे लिखूंगा number of moles of O2 कितने हैं, 1.89 moles of O2. यहाँ पे मैं लिखूंगा 8.37 moles of neon. इतना आपको याद रखना है. Now you can make this very formula. You know, since therefore mole fraction of O2, it will be equal to number of moles of O2 कितना, 1.89 divided by number of moles of O2, 1.89 plus you can have 8.37. It is the number of moles of neon. You can write 1.89 divided by, first you can add these two. You will have 1.89 plus 8.37. It is 10.26. Then you can bring this calculation. 1.89 divided by 10.26. It is 0.18. याद रखना. What is the mole fraction of O2? It is 0.18. Now you can determine its partial pressure. How you can determine it now? You can write, therefore, partial pressure of dioxygen. Mole fraction हमने calculate किया, that is 0.18 into the P total, that is 25 bar pressure. ये तो problem में दिया है. When you calculate this, what you can calculate, which value you will determine, you will have 0.18 into 25, you will have 4.5 bar pressure. It means that partial pressure of dioxygen, it is 4.5 bar. In the same way, you can determine the partial pressure of neon. Procedure is same, but the only one thing is you have to determine the number of moles of this oxygen and neon. You can use the same trend. Similarly, what you can write, partial pressure of neon, it will be mole fraction of neon into the P total. This is the formula you have to use, but what you have to calculate, since mole fraction of neon, it is number of moles of neon, ये हमने already calculate किए हैं, divided by total number neon plus dioxygen. You can write it as, you can write, therefore, mole fraction of neon is equal, number of moles of neon कितने हैं, 8.37 divided by, you will have 8.37 plus you will have 1.89. If you bring this calculation, you will have 8.37 plus 1.89, you will have 8.37 divided by 10.26. You can bring the calculation now. 8.37 divided by 10.26. You will have 0.81. It is the mole fraction of the neon. It means that to determine the vapor pressure, partial pressure of a gas, you must have to determine the mole fraction. To determine the mole fraction, you must have to first determine the number of moles. Now you can determine it, you can calculate it. Therefore, partial pressure of neon, what is the mole fraction? We have calculated 0.81 into what is the total pressure? That is 25 bar. When you calculate it, what you will have? 0.81 into 25. You will have P neon. You will have P neon. It will be equal to 20.25 bar. Remember this point. It means that whenever problem comes on this to determine how to determine the partial pressure of a gas in a mixture, you must have to determine the mole fraction. To determine the mole fraction, you have to determine the number of moles. Remember this point. Now you can solve more problems on Dalton's law of partial pressures on this very application. Now we have to discuss very important topic. Next topic from the syllabus, that is kinetic molecular theory of gases. This is a very important topic. Kinetic molecular theory of gases. Kinetic molecular theory of gases. kinetic molecular theory of gases, very important topic, or you can say it microscopic model of gases. Microscopic model of gases. You can also write dynamic particle model of gases. Particle model of gases. Kinetic molecular theory of gases, or microscopic model of gases, or dynamic particle model of gases. First, I will give this brief introduction about this. Then, for the examination purpose, for the remaining syllabus, you have to simply remember the postulates of the theory. Kinetic molecular theory of gas is a theory, and you have to remember the postulates. But before discussing those postulates, first I will tell you the basics of this very theory. First, if I will tell you kinetic, what the kinetic means. As per this theory assumes that the gas molecules, they are in motion. They are in continuous motion. Kinetic means motion. Remember this point. Well, as per this theory, the gas molecules are in motion, continuous motion. Hence, we have the word kinetic. So, kinetic simply means the gas molecules, they are in motion. Remember this point. Now, if I will tell you what is microscopic model of gases. Yeah, kinetic means dynamic. Dynamic means they are in motion. Remember this point. What the microscopic model of gases? What the microscopic model of gases means? Because this theory assumes that a gas molecule is made up of very small microscopic substances, microscopic particles. अगर हम इस थ्योरी की बात करेंगे, ये थ्योरी ये कहती है कि ये जो गैस है, it is made up of small, very small microscopic particles. Those particles can be either atoms or those can be either molecules. For example, हमारे पास है helium gas. It is made of helium atoms. If we have oxygen gas, we have oxygen molecules, but they are microscopic in nature. Hence, we have the word microscopic. You have to remember the first point. Why this theory, the kinetic molecular theory of gases? Because this theory assumes that the gas molecule, they are in continuous motion. They are in continuous movement. And what the dynamic means, same dynamic means in motion. What the microscopic means, it means that the gas, every gas is made up of very small microscopic particles that can be atoms or that can be molecules. Now, we will first see why this theory has been put forward in the chemistry, why it had been put forward in the chemistry. Then we will discuss who put forward this. हम यहाँ पे दो चीजें, ये क्यों केमिस्ट्री में आ गई. रिमेंबर दिस पॉइंट. द सेकंड वी विल डिस्कस ये थ्योरी किसने दी है. अब यहाँ पे देखिए, why this theory has been put forward in the chemistry. You know that हमने gases पढ़ी है, and you know that gases have some properties. आपने gases ये पढ़ा कि they have low densities. Gases have low densities. ये experimental fact है. They have low densities. अगर हम देखेंगे gas molecules, they occupy greater large volumes, hence the density will be low. When the volume is high, density will be low. It is experimental fact. हमने ये भी पढ़ा है gases are highly compressible. Compressibility of gases, it is a property of gas. Compressibility is the property of gas. Gases can be compressed. When you increase pressure, beta molecules नजदीक आएंगे and gas will be compressed. ये भी experimental है. You can go into the lab and check it whether it is correct or not. It means it is experimental. इसी तरह हमारे पास we have the low gases diffuse. Diffusion of gases. If you open the cork of the LPG gas cylinder in a room, gas will come out. That will diffuse from high pressure to low pressure. It means that diffusion, it is experimental, and other properties of the gases, either it is the low density or it is the expansibility. Gases expand, expansibility. It is another property of the gas. These properties of the gases, they are experimentally based. They have experimental base. Remember this point. The second thing, we have discussed gas laws. And when we have discussed the Boyle's law, Charles' law, Avogadro's law, all the gases are based on experiments. All gases are based on experiments. It means that either it is the gaseous properties or it is the gas laws. Both have experimental base. Both are experimentally based. Remember this point. Chemists have tried to give the theoretical support either to the gaseous properties or to the gas laws. This is the first point why this theory have been put forward in the chemistry. ये theory chemistry में क्यों लाई गई? इसका मतलब what was the main motive behind this? एक motive ये मैंने बोला है, ये जो gaseous properties है, they are experimentally based, and the gas law they are also आपने जब Boyle's law पढ़ा, आपने experiment पढ़ा है, प्रेशर ज्यादा करेंगे वॉल्यूम कम होगा, ये एक्सपेरिमेंट है. चार्ल्स में टेम्परेचर ज्यादा करेंगे वॉल्यूम ज्यादा होगा, एक्सपेरिमेंटल है. इट मींस दैट आइदर द गैसेस प्रॉपर्टीज और इट इज द गैस लॉज, दे आर एक्सपेरिमेंटली बेस्ड. टू गिव देम थ्योरेटिकल सपोर्ट, इस गैसेस प्रॉपर्टीज गैस लॉज को थ्योरेटिकली सपोर्ट के लिए, theory to explain the gaseous properties and gas laws on the basis of a theory. This theory has been put forwarded in the chemistry. Remember this point. First point, to give the theoretical justification to the properties of the gas and to the gas laws. This theory was put forwarded in the chemistry. You will remember this. This is the first point you have to mention in order to give the theoretical support. This is the first point you have to mention in order to give the theoretical support, in order to give the theoretical support to the properties of the gases, properties of the gases. जितने मैंने आपने बोला लो डेंसिटी है, compressibility है, expansibility है, to in order to give the theoretical support to the properties of the gases and to the theoretical support to the various gas laws, to the various gas laws. Remember, this is the first point you have to mention in this theory. In order to give the theoretical support to the properties of the gases and to the various gas laws, this theory was first proposed by, first put forwarded by Bernoulli. याद रखना, Bernoulli in 1738. This was the first attempt. Bernoulli was the first who put forwarded this theory. Remember this point, put forwarded by Bernoulli in 1738. This was later on modified by it. This was later on modified. This form was later on modified by four chemists. Remember this point. Four scientists modified by Boltzmann, Croning, and we have the Maxwell. This was later on modified by Boltzmann, Croning, Maxwell, and Clash. Around this point, in 1860. याद रख, पहले आपको याद रखना kinetic molecular theory of gases. Why kinetic? Because the molecules, they are in continuous movement, hence they have used the word kinetic. Why microscopic? Because this theory assumed that, regards that the gas molecule is made up of very small microscopic particles that can be either atoms or they can be either molecules. And why this theory was put forward? In order to give the theoretical support to the gas laws and give the theoretical support to the properties of the gases. You know, gas properties, they are experimentally determined, they are experimentally based, and the gas laws are also experimentally based. To give them theoretical support, this theory was put forwarded in the chemistry. And who put forwarded it? It was put forwarded by Bernoulli, and they later on modified by the Boltzmann, Crowning, Maxwell clashes in 1860. On this point, you can also remember this kinetic molecular theory. This theory was proposed in order to derive the mathematical forms of the laws, gas laws. For example, if you have the Boyle's law, PV is equal to constant, you can derive it from the theory. If you have V by T is equal to constant, you can derive it from the theory. You can also remember it is that theory from which the mathematical forms, from which the gas laws can be mathematically derived. You can also remember the theory from which the mathematical forms of the gas laws can be derived. That theory is also known as kinetic molecular theory of gases. You can also write it is the theory from which you have to remember, from which gas laws can be mathematically derived. It is the theory from which gas laws can be mathematically derived. It means that now we have to discuss this very important topic, that is kinetic theory of gases. Inshallah, we will discuss the various postulates of this theory, inshallah, in the next lecture. Fi amanillah.